So up until now, we've done a couple of things, both with spreadsheets and with Excel functions. We've looked at how we can determine how much a lump sum amount will grow to after a certain period of time, given a particular interest rate and number of compoundings. We've also looked at how to determine the annual percentage yield or the effective rate. So now what we're going to do, we're going to open this video with looking at how could I determine how much I might want to put in today if I wanted it to grow to a desired amount after a certain amount of time. So here's the first example. Suppose you're planning to buy a car in 5 years and you want to be able to have $2,000 to put down. In order to encourage you to save money, your parents have agreed to pay you a unheard of APR of 12%, much higher than anything that you would find. And although if you ask your parents and maybe grandparents in the 70s and 80s, there were rates out there that were in the at least near that in the double digits, and definitely not going to find that today, but to try to encourage you to save. Suppose this is what we could get. And they're going to teach you a good math lesson. They're going to compound interest quarterly. So how much would I have to give my parents today? Maybe they're trying to encourage a child who has a really good summer job just to put that money away and save it and not just spend it, let's say. So let's think about what would we have to give our parents today in order to have $2,000 in 5 years. So we could start with just a guess and check trial and error. So if we are having interest compounded quarterly, going back to a spreadsheet, we would have to extend this list until we get to 20 quarters. So remember, the double highlight, click and extend is just for creating a quick list of numbers, get it down to 20 quarters, that would be 5 years. The beginning balance is what I don't know. So let's say I just started off, I'm going to say, what happens if I give them $1,000? And my interest is going to equal, they're giving me this wonderful interest of 12. Again, you can just use the percent sign if you want, or you can convert it to a decimal, 0.12. But either way, we have to remember to divide it by our number of compoundings, which in this case is 4. So basically, we're going to get like 3% interest every quarter. So every few months, they're going to factor in 3% interest. And then we multiply that by our beginning balance. So this is how we started learning to set up spreadsheets in Excel. Our end balance is going to be our beginning balance plus our interest. And then our new beginning balance would equal our old end balance. And then we could go to each of these end values and fill our spreadsheet. And we would see that $1,000 would grow to $1,806 under these conditions. So we'd have to put in a little more. So now, beauty of Excel, suppose I up that to 1,300. And everything changes based on that initial cell reference. And I go down, and now I see I'm over what I need if I'm just trying to get to 2,000. And so we'd close in, right? So we'd maybe 1,000 wasn't enough, 1,300 was too much, maybe we go to 1,100 or something. And so you could continue and say, oh, I'm getting pretty close here at 1986. So you could continue to guess and check your way. And in the notes, I show that if we would enter 1107.50, we're getting real close. But there has to be a more efficient way than this, and there is. So we can close in on it pretty well. But we're going to want to do a more precise and less guess and check method to do this. So this is what we're going to look at. It's a way to use the future value command that we know, that function, along with some other functions that are in Excel, some other features, I guess I'll say. So we want to go to any empty cell and start with equals, and FV should probably be in your recently used ones. And our rate in this situation is that 12%, read your reminder at the bottom, divided by your number of compounding. So in this case, divided by 4, it is quarterly. The NPER, total number of payments. In this case, we're doing it for 4 quarters a year times 5 years. So we have 20, just like what we extended our spreadsheet till. The payment, this again is not a regular payment situation. We are going to get to that today in this video, but right now we're not putting away money every single quarter. Instead, we have no lump sum. I'm sorry, we have no regular payment, and instead we're putting in a lump sum. Kind of think of that scenario. I said maybe a kid has worked a job, and at the end of the summer they have a lump sum, and the parents are trying to encourage them to save it. So this is what I'm trying to figure out. This is my unknown. And if you remember, what I've been saying all semester to my students is an unknown in algebra is a variable, and in Excel, it's a cell reference. This is what I'm trying to find. So what I'm going to do is I'm just going to cell reference an empty cell. And it doesn't matter what one, you just have to remember which one you've used in the next step. So I used the one right below it, it was F2. And then you're going to hit OK. Now, right now you're going to get 0, which makes sense because we just cell reference an empty cell. So an empty cell is going to grow to 0. We're not going to have anything there. But now what we're going to do is we are going to go into your top ribbon up here. You want to go into your Data tab. And again, these directions are all in screen captures in Excel. We're kind of down to this part right here on page 184 over to page 185 here. So you want to go to your Data tab, and then you want to go into your What If analysis, which mine has sort of gotten condensed down because I have this. I'm going to make this a little, hold on just a second here so you can see. Make this a little wider just for the time being. Okay, so we went to Data, and then we're going to What If analysis, and then you're going to use the goal seek. So we're planning for a goal, right? We're planning to get $2,000 in 5 years. I'm planning for a goal. So I want to set the cell that has my future value in it. Yeah, that's the future value that I want to set. So whatever had the 0 in it, that's the one I want to set to the value of, I want it to grow to $2,000. This is really like an equation. So I'm setting what I had in that formula, which was in F1, I'm setting it to the value of 2,000 by changing whatever cell I have as my variable cell, that one I cell referenced for that lump sum amount. So for me, that was in F2. So I used the one right below it. And then we're going to hit OK. And what we get to is 1107.35. So we see that, again, if I wanted to kind of double check that, let's go back to my spreadsheet. It's real close to where we left off. If I change that to 1107.35, that's going to get me as close as I can to the nearest penny to $2,000 in these conditions. All right, so that is the future value / goal seek process that we can use to plan for a goal. So we'll come back to that later as well when we start planning for other things as well. All right, so now what we want to kind of continue to do here is we want to continue to look at savings, but we want to get into looking at regular deposits because that's more realistic. The chances that we get a windfall of thousands of dollars that we can just throw into an account doesn't happen as often. Sometimes graduations or life events and you get a lump sum. But more often than not, what's more reasonable for more people is to be able to put away a little bit of money every paycheck. A little bit of money, let's say every month, is how we're going to define that. And this really gets into retirement plans. This is a weird time for me to be making this video because in some ways I am often encouraging students to participate in their employers' savings plans like 401ks, which are employers often will sometimes even match a certain amount, like you put in a certain amount, and your employer might put in a certain amount every month. But most of the time, these are going to be invested into a variety of different types of things in the stock market. And so I know right now that's a very scary thing to say to people. So I'm not a financial analyst, so I'm going to talk about the math of what happens when you start early. And so even if you did something really, really conservative with a low interest rate, I want you to walk away with the math lesson of starting early, because that is the important lesson here. And so that's what we're going to start looking at here. So this is my key idea. It's important to participate in retirement plans at work and to start early. One of our lessons is going to be there is no replacement for time. So that's what we are going to start to take a look at here. All right, so suppose that at the age of 30, Malcolm starts something called an IRA. It's an individual retirement account, and just think of it as a big savings account. Okay, so for just all intensive purposes, there's lots of different retirement accounts out there. One time at the end of a semester, I had a student that was really interested. He was already participating in his employer's 401k, but he wanted to know more. And I put him in touch with one of our business professors who knows a lot about finance, and he was able to get more information there. So for right now, for our purposes, I just want you to think of it as a savings account. And he decides that he can comfortably deposit $100 each month, so 25 bucks a week. He figures, okay, I can do that. And we're going to start off assuming an APR of 6%. And so that is if you talk to most people, this is such an unheard of time that we're living in, but an APR of 6% in the long term is a very reasonable amount to expect that you could earn in retirement accounts. A lot of them were doing better than that prior to the coronavirus, and which has really kind of brought everything to a bit of a halt. So we're going to assume this 6% monthly, and we're going to look at what he would have. So interest paid monthly, compounded monthly, what would he have in 35 years when he plans to retire at the age of 65? So we are going to set this up first with a spreadsheet. So the only thing that's going to be different than our other spreadsheets is that we now have a new deposit column. So we're going to have some months, beginning balance, interest, a new deposit, and then an end balance. So the first thing we need to figure out is just simply how far am I going to need to extend this? Well, if I'm going to have 12 months a year times, and I'm doing this for 35 years, then I need to go all the way down to 420. So we're going to double highlight on the 2 and the 3, pull down in that lower right-hand corner, and we're taking it all the way down to way too far, 420. All right, so I just looked away for a second and I went way too far. There we go. Now, I am always going to give you one of two scenarios, either a lump sum amount and no regular payment, so some sort of beginning balance, that's what we've done before, but no regular deposit, or what we're doing now. So we're going to start off assuming no lump sum amount to start, and instead it's going to be this new deposit that we're going to have. But the interest, obviously right now it seems silly to figure out interest on $0, but we're setting this up for the entire spreadsheet, so we're going to do the same type of interest calculation that we've always done. So 6% or 0.06 divided by, this is going to be monthly, compounded monthly, so divided by 12, and then times cell referencing your beginning balance. And then hit enter, obviously $0 still. The new deposit amount is going to be 100, and that's going to be a constant regular 100, so just type in 100. And now the end balance. So thinking it through, we have the beginning balance plus whatever we make in interest plus whatever we have in this new deposit. So at the end of this first month, we just have our $100, right? We just put in that 100 bucks. And that's what we're going to start our next month with, is this 100. And now that we have that new beginning balance in that new month, now you can go back up to each of your formulas and double click or click and drag. And let's look at what we would have at the end of the 35 years. So scrolling all the way down to month 420 here. So after 35 years, we have $142,471.03 approximately. So that seems pretty good. But what we really want to think about is, well, yeah, I mean, I was saving money for 35 years, so I have a lot of money. What we really want to look at is how much did I put in versus how much did I make in interest? So how much money did I get for free in essence? So when we think about Malcolm deposited $100 for 420 months. So just in any empty cell, if you wanted to, you could either auto sum this column of new deposits, or just think about, especially when we start not setting it up with a spreadsheet, it's just thinking about, okay, if I make a $100 deposit times, I do it for 12 months a year, times, I'm doing it for 35 years, that's that 420. So I put in 420, I'm sorry, not 420, just 42. So I put in 42,000 of my own money. So Malcolm put in 42,000 of his own hard-earned dollars. So think about that. 42,000. The rest was from interest. So the remaining 100,471. So when you think about that end balance minus what you actually deposited yourself, that remaining 100,000 plus, that is how much was made in interest. So this is really the power of compounding. It's the power of starting early and then having time to let that money grow. So, oops, I did not mean to just do that. I just wanted to remove the one there. So we end up with this $100,471.03. That all was made in interest. So I said over here, if you wanted to figure out the total, you could have summed that column. But many times I'm not going to require you to set up a spreadsheet at all. I might just ask you to do it with the future value function. So let's look at how we would have gotten that same amount here, but using the FV function. So remember, any empty cell, FV should be in your recently used. The rate, most of this is just like before, so the 6%, remember here, divided by the number of compoundings. There's your reminder at the bottom. So in this case, it's monthly, so divided by 12. Total number of payment periods in investment. This is a long one, so I just have Excel do the arithmetic. So it's like, how many times am I putting in money? Well, I'm doing it for 12 months a year times 35 years until I retire. So there's the 420 payments. Those were the number of rows in our spreadsheet. And this is now where we're doing this payment made each period. So I am putting in $100 every period, which in this case is every month. And nothing in the PV because I don't have a lump sum. So I'm always doing one or the other with you. So you can just leave it blank. And so there it is. Again, here's this little weird quirk in Excel. The future value function always comes out negative, which a lot of times comes out red. For some reason on this one, it didn't on mine. It came out as a negative, but watch for both. So make sure you're able to do the future value function. But again, especially if this comes out red, do not just take this minus, let's say, the 42,000, because remember that's negative. So don't ever cell reference the negative or the red number. All right, so obviously we got the exact same thing there. All right, so let's look at, so that's where we ended right here. Now let's look at another example here. So now suppose that he didn't start so early and instead he waited until the age of 45. But let's suppose that he recognizes that, you know, I get it. I waited, you know, maybe I shouldn't, I waited too long, right? So I'm going to double how much I put in. That's a reasonable thing to think. So now let's think about what happens if he does that. But this time he's 45. He only has 20 years to go. So now 20 years times the 12, that's going to put us at the value at 240. So this time, where's 240? I went right past it. If I do my spreadsheet, I'm going to delete everything here that's below. So now I'm just going to the 12 times 20, or 240. But this time we are going to put in a new deposit is going to be $200. Everything else is the same, though, the interest. Be very cautious when you do this, though. I'm doing this on purpose so you notice something. Notice when I change this one value, it only changed this cell. If you change, it's probably always safer just to start a new spreadsheet, especially if, like, let's say you just change the interest rate. You may feel like you've changed everything, but you've only changed that one cell. You would need to refill that column. So now that I've done that, it looks like I'd only have $92,408. So again, we could also do that with our FV function. So we'll just go equals FV. So the rate, once again, this was our 6% divided by 12. This time, 20 years times 12 months a year. And my payment, though I'm doubling, is going to be $200 a month. Okay, so there it is, same thing. So I doubled the amount I was putting in each month. So keep in mind, what did that really do for the total that I put in? So the total that I, or Malcolm, put in is still going to be monthly payment, this time 200, times, I did it for 12 months a year, and this time I did it for 20 years. So this time I still put in, well, actually I put in a little bit more. I put in almost the same amount, actually put in a little bit more. So in this situation, I actually put in 48,000 to end up with less. So kind of observe that. That's an important observation, that in the first situation, I ended with 142,471, and I only put in 42,000. Here, I put in 48,000, and I only got up to 92,408. So I put in more, and I ended up with less because I didn't start early. So the power of compounding really comes from starting early. All right, so that's what we were looking at with that example. All right, so now suppose we wanted to figure out, okay, so suppose that I wanted to figure out, well, what would I have to put in each month in order to get to that same initial amount, that 142,471? What would I have to put in every month in order to get to that same amount we had initially if I did in fact wait until I only had 20 years left to plan for retirement? So we're going to do that goal seek process again. So now I'm planning for a goal. How much should I put in today? So we go to an empty cell, equals, and we do our future value function. I'm just going to do my recently used. I meant to do it right here. All right, rate. Again, 6% divided by 12. This time, 12 months a year times, I've only left myself 20 years to get it done. Payment. Now, that's what I'm trying to figure out. This is my unknown. I'm planning for a goal. Unknowns in algebra are variables. In Excel, they are cell references. So I'm going to tap on cell below it, which is cell B246, but the one below it. And I'm going to hit OK. So right now it's going to still be nothing because I cell referenced an empty cell. So now we're going to go into our Data tab at the top and the What If analysis and Goal Seek. So I want this future value amount. I want that cell, yep, that's the one I want, to be, and it was what, 142,471. I was trying to get to that same value we got in the first scenario. And the cell I'm changing is my variable cell. It's whatever cell you clicked on when you first set up your FV function. So for me, it was the cell right beneath it. It was cell B246. And then we hit OK. And so it tells me I'd have to put in 308.35 in order to get to that same amount. So if I wanted to model it in C, so what did I just say it was? I already forgot. 308.35. I remembered 308. I forgot the pennies. All right, so if I did 308.35 and I did that again every month for 20 years, that's what it takes to get me up to that roughly, this is as close as I can get, 142,470.31 cents. And so in this situation, this time I would be putting in of my own money 308.35 times 12 months a year times 20 years. So here I put in $74,000 of my own money to get to what in the first scenario, if I allowed myself 35 years, I only put in 42,000. So, you look at that and that's, it's a big difference. So it's this power of starting early. That's the power of compounding. So those last couple of examples sort of pulling that together, if you started at 30 and only put away 100 a month, that was 42,000 of your own money. And so you ended up with 142,471, right? So you made 100,000 in interest. In scenario 2, if you waited until 45, you'd have to more than triple your monthly deposit. You'd have to put in 308.35, and you'd have to do that for, again, the next 20 years, and then you'd end up putting in more money. You'd put in 74,000 of your own money instead of 42,000 to get to that same amount. So definitely always want to start saving early. Even if you're in a really low interest, very secure saving situation, it's always better to start early. So now let's look at one other kind of really good scenario here. So now let's say this is somebody sitting in this class right now at the age of 20 and saying, okay, well, what would I have to put in if I started today at age 20 in order to get to, again, this same, it's just our original question, that same 142,471. Okay, so once again, let's go through that goal seek process. I can go back to the same one I had set up with the future value function, where I had cell referenced the cell below as the regular payment variable I'm trying to solve for. So we can go up to our data tab and our, make this bigger so that pops up, our what if analysis in goal seek. And I was tapping around here, so I need it to be the cell that had the future value function in it. So it's this cell. I need to set it to be the value of, I'm trying to grow to that 142,471. And by changing that cell B to 246. And so, wait a second, I must have typed in the same thing because that was the same thing I just had here. I must have just typed in the exact same thing. Oh, I did. That was my fault. Sorry. The one we did before was based on that I waited until I only had 20 years left. I needed to change that time. See, it's always dangerous working off of previous ones, just trying to save time. Sometimes we forget there was other things that changed. Sorry about that. So let's go back. Equals, do it from scratch. FV. Rate is our 6% divided by 12. Now, this time I am starting at the age of 20. So that means I have, 45 years until I get to 65 times 12 months a year. That's 540 payments I have the luxury of putting away. And this is, again, my unknown, the regular payment that I'm trying to figure out. So that's where I'm going to cell reference, the cell below it, it's cell B246. And I'm going to hit OK. And now I'm going to go to my data, my what if analysis, and my goal seek. I'm going to set that cell to grow to the value of 142,471. And I want to change my variable cell, which for me was the one right below it. And so now I find out that I would only have to put away 51.69. Again, that's to the nearest penny, obviously, in order to grow to that same amount. So if we think about that 51.69, and I do that for 45 years times 12 months a year, it seems like, oh, I bet I had to put in more. No, we didn't. We put in less. We only put in a little under 28,000 of our own money, and we ended up with that same amount, but we put in even less. So once again, if we now compare and pull all these together, so we can see that, didn't mean to tap that. Now, if I started at age 20 and I had that extra time, I'd only have to put in a little under 28,000 of my own money to get to that same amount by the age of 65. So the moral of this story, kind of the end of this video here, is there is no substitute for time. So while our stock market right now is under some crazy unheard of times and pretty scary for a lot of people, and they say, especially for folks that are nearing the end of their retirement, as opposed to if you're young, you still have a lot of time, things will bounce back. That's what we all are hoping. So my lesson is not to try to tell people, I don't want anyone to go home and tell your parents that I'm telling you to dump all your money in the stock market. I'm just trying to teach you the math lesson of the power of investing early. So even in like really secure, low interest rate situations, starting early, there is no replacement for time in terms of saving and planning for retirement. All right, so you're now set to go here for group activity 19. And again, I think I'm just going to leave all parts of that group activity. I don't think I'm going to take anything out there.